Hi, this lecture is about Google VPC with a security perspective. What is a VPC? VPC is a logical network in the cloud with an RFC 1918 address space. It is similar to physical network in the data center. Google is going to manage the VPC and it is going to take care of the routing for you. There are three possible configurations. The first one is default VPC. This is created by Google by default. And this is global scope and it has default firewall rules. Global scope in the sense it is going to span across all the subnets and across all the regions. I'm going to talk about the default firewall rules with the default VPC at a later point of time. The second one is manual VPC with a auto mode. This is again going to span the global across the globe and it has no firewall rules. The third one is manually configured VPC with manual mode. This is subnet scope in the sense you can pick and choose which subnets needs to be included in your VPC. And also this one doesn't have any firewall rules. As a security professional, this is a preferred choice for me because I can control where my resources are going to reside and where my data is going to reside. That way I don't have to worry about cross-border data movement and some other compliance issues. Also, this one has no firewall rules. It means it helps you configuring whatever firewall rules you want. This is how the auto mode VPC looks like. As you can see, it has subnets from Asia, Europe, North America, South America. This is an example of manual mode VPC. This one has subnets from US East 1 and US West 1. This way you can control where the resources are going to reside and where the data is going to reside. Routing. Default VPC out is provided by Google. It means all your resources can reach internet without having to do any additional configurations, provided they have a public facing IP address. The next one is default private access. We are going to talk about private access at a later point of time. The third one is subnet to subnet routing. By default, Google is going to set up routing between all the subnets. In addition, you can have manual routes. For example, you don't want to use the internet access provided by Google. You want to route the traffic through your data center so you can utilize existing DLP controls and other controls. In that case, you can manually set up a route so that traffic goes to your data center first, then goes out. If you are using a cloud router, it is going to publish BGP routes automatically for you. Now let's have a look at firewall. Each firewall rule has 4 properties. The first one is ingress or egress. The second one is allow the traffic or deny the traffic. The third one is priority. Number 1 is the highest priority, 65535 is the lowest priority. The last one is target. Based upon the ingress or egress, the target is going to change. Now, how do we associate the firewall rules to the resources in the VPC? The first option is you can associate any firewall rule to all the resources in the VPC. This is going to help if you want to enforce the rule across the VPC. One example, if you want to limit access to your VPC only to your data center, you can configure two firewall rules. The first rule is a whitelisted IP address of your data center and which will allow traffic into your VPC. The second rule, also an implied rule, is going to deny all other traffic. That way you can control access to your VPC and all your resources. IP whitelisting is not a very good form of control. Keep that in mind. The second one is by matching tag. Here, whenever you define a firewall rule, you give it a tag. And if you give the same tag to any other resource or a virtual machine, it is going to assume the firewall rule. This one is a little bit complicated in the sense if you have a lot of resources and by accidentally if you mismatch your tags, it may open up a hole in the security. For example, if you have a rule for allowing internet access and you attach it to a database server, is going to cause problems. If you have a strong CI/CD, you can avoid those kind of problems. The third one is service account. So you can associate your firewall rule with a service account. And if you use the service account, the resource is going to assume the firewall rule automatically. For example, you configure internet access and assign it to a service account and use the service account on all your web servers. Then all the web servers are going to get the internet traffic. Implied firewall rules. This is common for all the VPCs. The first one is egress rule. This allows all traffic from all IPs to go out with a priority of 65535. If it is going to reach the destination or not depends upon the destination firewall rule. The next one is ingress. Deny all incoming traffic from all IP addresses with a priority of 65535. Now let's have a look at the default VPC firewall rules. There are four firewall rules with the default VPC. The first one is ingress default allow internal. That means all the internal traffic is going to be allowed by default. The next one is allow SSH. If you want to do SSH into your Linux instances. The next one is allow RDP. If you want to do RDP into your Windows instances. The next one is allow ICMP. And all these have a priority of 65534. This is the higher priority than 65535. That way these rules are going to overwrite the implied firewall rules. If you are configuring your VPC for Kubernetes cluster, there is an option you can configure which is private cluster configuration. And this will isolate your cluster from all the external traffic. In that case, if you need to access the control plane, you have to whitelist the IP addresses. Again, whitelisting is not a very strong form of control. Now let's have a look at an example. In this case, we have two VM instances which are having incoming firewall rules. We also have two instances with external IP addresses. You can see this VM can reach this VM and also this VM because both of them have incoming firewall rule. Whereas this VM cannot reach this instance because this has no firewall rule associated with it. Also, you can see this VM can get the external traffic because it has an external IP address, and also it has a firewall rule which is allowing incoming traffic. Whereas if you see this one has an external IP address, but it has no firewall rule. Because of that, you cannot reach this VM instance from external source. Sharing and peering. You can share your VPC with another VPC within your same organization. Here you can share the entire VPC or a subnet. You can also do VPC peering with a different organization, but it allows only subnet level peering. So if you want to share your VPC with a different organization or with a partner, what you can do is create subnet and remit the resources in the subnet to whatever resources you need to share with your partner. That way you can limit the blast radius. You can also set up custom routes, and also you can set up dynamic routes. If you are setting up custom static routes, make sure you are setting it up right way so you are not routing the traffic to any unintended points. The next one is on-prem to VPC connectivity. You can use Cloud VPN or Cloud Interconnect to connect your on-prem resources with your VPC. The older form of Cloud VPN is called Classic VPN. The latest one is High Availability VPN. The Cloud Interconnect is a high-speed connection. I'm not going to cover BGP and route propagation in this lecture. Now let's talk about private access. Private access allows access to Google APIs and services without having the need for any internet access. It means the traffic is going to go on Google backbone and it's going to reach the Google APIs and services. As a security professional, this is a preferred choice for us because we are limiting access to internet. Here is an example. In this example, we have two subnets, one with a private access on, the other one doesn't have a private access. You can see this one has no public address, but it has private access and it can go and consume the Google APIs and services. And this one has a public IP address and also it has private access. So if it wants to consume the resources, the traffic will go like this. If it needs to consume internet resources, it will go like this. For this VM, it has no external IP and also it doesn't have private access. Because of that, you cannot reach the Google APIs either through external internet access or through Google backbone. The next one has a public IP and it can consume the Google APIs and services. The next one is private access from on-prem. If you want to consume Google APIs and services from your on-prem, you can set up a route such that you are going to go through your VPN tunnel, go through your VPC, and you can from there you can route the traffic and consume the Google resources. That way you don't have to go over an internet connection and consume the Google APIs or services. The next one is private access with your partner. If you want to have a private access with your partner, VPC networking is required. So once you have VPC network peering, then you can have private access with your partner. You can also extend this to your on-prem, in the sense from your on-prem you can use a VPC, come to your VPN, come to your VPC and consume your resources offered by the partner. Troubleshooting. Google provides VPC flow logs. Using VPC flow logs, you can do troubleshooting and also you can monitor your VPC. You can have 5-second flow logs. You can collect the flow logs at subnet level. You can collect ingress and egress at VM level, and no performance impact because of flow logs, because it is natively built into the VPC. Also filtering is possible. That means you can limit the traffic to certain by setting up a filter. The next one is VPC packet mirroring. This is similar to router span port. You can track all the traffic including header and payload and send it to a destination. You can limit it to the specified instances. You can include both ingress and egress. And also you can filter the traffic. The third one is firewall rule logs. As I mentioned, in certain scenarios, Google firewall rules are little complicated. By turning on the firewall rule logs, you can audit, verify and analyze and make sure they are working as intended. And you can turn them on and off whenever you want. If you are using VPC for a Kubernetes cluster, you can also log pod-to-pod traffic. So your VM is the node, and node will contain multiple pods, and you have the option of logging pod-to-pod. That means the traffic which is on a particular node can be logged. WAF. If you want to protect your VPC, you can associate a WAF at a load balancer level. Cloud Armor is the WAF provided by Google. If you want to get more knowledge, you can look at those links and get more knowledge about VPC. Before I close out, I want to talk about some of the patterns. If you want to share your VPC with your on-prem, one of the suggested patterns by Google is you create a dedicated VPC and terminate the VPN connections on the VPC. And you can share this VPC with all other VPCs. That is one of the patterns suggested by Google. The other one is if you need to have different VPCs for production and development. There are two options possible. You can have different VPCs or you can have one VPC with different subnets. As a security professional, my choice is to have entirely different VPCs if possible. It's a small disclaimer. This presentation is not representing the company I work for, and also the things change rapidly in Google because they are constantly evolving. So check back with their documentation. Get in touch with me. Thank you. Thanks for listening.